Hello and welcome to Book Bites, a book club podcast for developers. We're reading 7 Languages in 7 Weeks by Bruce Tate, and today we're going over the chapter on Prolog. I'm Adam Garrett Harris.
And I'm Jason Staten.
So, what did you think of this chapter? Or this language, I should say.
So, this language made me feel most like the meme of the dog on the laptop keyboard.
Yes.
Like that is exactly how I felt with it. Is
where the dog says,
really,
I have no idea what I'm doing.
Yes.
I know. It was so interesting. I'm really excited to talk about it.
Yeah. Yeah.
So I love how this language is compared to the main character in Rain Man, which I don't know if you've seen that movie. Have you?
It has been a long, long time. But
I don't know if I've seen it, but I know the concept. I've seen parts of it. He's basically a genius, but has no social skills.
That sounds very much like Prolog, especially after having worked with it a little bit.
It compares it to it compares the language to Raymond, where you'll find yourself asking in equal parts, how did he know that? And how didn't he know that? So he's a fountain of knowledge if you can just frame your questions in the right way. And that's the really interesting thing about it. You don't tell Prolog how to solve the problem.
Right. And instead you tell it the facts that exist and the rules that it needs to adhere to, or I guess the goals that it should set out to accomplish. And ultimately you get told, yes, this is possible, or no, it's not, according to those facts and goals.
Yeah. And then it will give you the first solution it finds, and you can actually say, give me another one, or give me all of them. Mm-hmm. It kind of reminds me, like, if you were to explain a card game to somebody, you would say, here are the facts, here are the type of cards, here are what the different icons mean, here are how they all relate to each other, there's different groups of cards, things like that. And then here's the rules of the game, here are things you can and can't do, and here is how you win. But you don't tell them step by step, first do this, or here's your algorithm for winning, or here's your algorithm for playing necessarily. It's like, here's the rules, here's the facts, you decide what to do.
Right. It's not saying it. Fact, there are 52 cards, and it doesn't necessarily say pick up card from deck. And
right.
And yeah, I would agree with kind of that premise. And that's actually why when later on it describes the language as being well suited to something like games, it actually makes sense, especially for things like AI, where if you think you have a character, for example, like if you are creating non-playing characters or just other interactive characters, like you can give a premise of like, given the rule that your player or the player is of rank 10 and it is of class mage or something like that, then this is the behavior that you should take when that person interacts with you or something. And it doesn't necessarily specify all of the logic to go and check all of that, but instead you're just stating, like, given this is the case, this is the way that you should respond back.
Yeah, it's definitely good for puzzles, for sure. Mm-hmm. And 2 of the most common ones, well, I guess really 3, there's Sudoku, mm-hmm. there's Towers of Hanoi, or however you pronounce it, and then another one kind of common is with chess, where you try to place n number of queens down on an n by n board. And in the book, it was 8 queens, because typically a real chessboard is 8 by 8.
Mm-hmm.
And well, you try to place them on a board where they can't hit each other or kill each other.
Right. Yeah. So you go and specify the places that they can actually move to, and then say that given I have all of these positions, there is in fact a way to position all of them to make that satisfy that goal.
Yeah.
Mm-hmm.
So I actually lied when at the beginning of this book we talked about which languages we had experience with, I had forgotten that I had done Prolog in college.
Really?
And I mean, I just remember there being this obscure language we did for a brief amount of time, and they kind of positioned it as a higher order language because it's not procedural. And I couldn't remember the name of it, but I do remember doing Towers of Hanoi, and I don't know if I solved it. I can't imagine solving it in college with Prolog, because it's, even seeing the solution now, it's very obscure to try to understand it. Or if we just talked about it. So they may have shown us the solution for Towers of Hanoi. There may have been some other problems that we solved instead. We may have done like a family tree type thing.
Yeah, I could.
But yeah, so I was very excited to see this again and remember that this was something I played around with in college.
That actually relates to a coworker of mine that I talked to, where I told him that I was working on Prolog, and he said, yeah, when I was in college 20 years ago, we did Prolog. And so I remember none of it, but I remember doing it in college. and so I told him about it, and he said that sounds great. And he liked the idea of it from the kind of AI standpoint, and even brought up that it's kind of related to how we handle like the deep learning type of approach these days, where like we have lots and lots of known facts of like, this is an image with a cat right here, like that is a fact that I know. Yeah. And then based on that, like you go and give it ultimately other images, and it can say that like whether or not that's there. The major difference being that Prolog would want more of an absolute, I feel like.
Yeah.
At least in my experience of, yes, that is 100%, or no, it is not. Whereas kind of
I feel like
learning,
in Prolog is not as much of a black box. It can be a black box to figure out how it came to certain solutions, but I feel like there could always be a way of stepping through it and seeing how it came to that solution.
Yeah. So I guess where machine learning is more on probability, Prolog, you can know, and sometimes do you even have to know, as it kind of explains in the final part of the chapter, where because it takes like a depth first approach, sometimes you have to guide it along, or try and do things like having tail recursive type goals that exist. And if you don't structure it that way, like it pretty quickly will go and blow a stack.
Yeah. Can you explain tail recursion really quick?
Yeah. So in normal, well, I guess normal programming, like commonly in programming.
Prolog is not normal programming.
Right.
So yes.
So and so like my explanation of it is definitely on the basis of not Prolog. So I could be totally botching it on it, but a tail call in programming that I'm familiar with is the last when you make a call of like from one function to another function, just in most programming languages, you write a bunch of say maybe local variables, and then you go into the next function deep, and it maybe creates local variables, and then when that finishes, then all of its variables are thrown away and you move back up the stack. And so you like, as you get deeper and deeper in function calls, your stack grows bigger and bigger, and as you finish a function call, it pops off the top of the stack. And if you do that too many levels deep and use too much space on the stack from variables and keeping context, then you can get a stack overflow where your program crashes. And
so Stack Overflow is not just a website where you can get answers.
No, but it is also something that you can run into if you recurse too deep. But if you are using a language that supports tail call optimization, then what can actually happen is rather than growing the stack, it can actually, if you go and the last function or last call within a function or is that same function itself, and you do no additional operations, you don't like add the result afterwards or anything, then it can reuse that same stack frame again. So rather than growing the stack, it will actually reuse that same head position again.
Okay.
So it'll pop and push or something like basically like that, where it doesn't grow the
I think
stack
it's
anymore.
not like, I don't think it's reusing the same position. I always understood it as it was able to let go of the old memory because there's nothing it needs to hang on to anymore.
Right. Yeah. I mean, it's because I mean, you ultimately do have all of the stack beneath of it, but it's not growing anymore.
Yeah.
And speaking of getting it entirely wrong, I have a ancient blog post on my website that I wrote about tail recursion in Haskell, and which we will get to, but I made assumptions on how it worked, and I was actually completely wrong about it. And I posted the thing on to the Reddit group and on Haskell, and yeah, they just ripped me apart and said you're completely wrong because they don't actually handle it the same way. And so yeah, fun fact, like not every language handles it quite in the same way. And Prolog, I very well could have been wrong on that, but that's basically how I understand tail call optimization or tail call recursion.
Yeah, and tail call recursion is one of the more advanced things later on in day 2 or 3. Yeah, it's in day 2. But maybe we should come back to that in a second.
Okay.
So like really basic Prolog, you put in some facts, and I love that one of the most basic things you can do, understanding hardly any Prolog syntax at all, is the map coloring problem, which is a very difficult problem. And you can just say, hey, here's some rules. Red and green are different. Red and blue are different. Green and red are different. You just say all these different colors that are different from each other. Okay, easy. And then you say, those are facts. And then you have a rule that says when coloring, they do like 5 different states in the Southeast United States. When coloring in these 5 different states, the states that are touching each other must be different. And that's it. And then you just do a query where you're like, okay, coloring, you pass in a variable for each of those 5 states. And then it says, okay, Alabama's blue, Florida's green, Georgia's red, so forth. And then it will give you every single combination. And it's done in like 2 lines of code. I mean, it depends on how you write it. It's like 7 statements.
And I think one of the parts in the chapter says, like, where is the algorithm or there's right. Where's the program? Like, because all you're telling it is these are the rules that it has to adhere to, and then Prolog says here are the possible ways that those rules can succeed.
Yeah, and you could do like more basic things. You could say, hey, Prolog, what colors are different from red? And it would give you every other color. Or you would say, hey, Prolog, are red and green different? And it would say yes. Or is red and red different? And it would say no. So it can do really basic stuff, but then you can start querying more things. So like your program is like a database, and then you load that database into the Prolog listener. So the Prolog listener is kind of like a REPL, and then you can write code in there, but mostly I'd say what you're doing is loading programs and then running queries. Does that sound accurate to you?
I mean, that sounds pretty fair to me. That was actually one thing that I couldn't get going on my own was or figure out is like running a Prolog program directly from the command line. Like it always got the REPL going. I figured out and this is in particular to G Prolog where
GNU Prolog.
GNU, yeah. So you can specify a flag to say this is my entry goal and to consult file, which means to load it like you do.
Right.
And so
I saw that
I was able to use that.
You could run consult, or
Mm-hmm.
you can just do square brackets with the name of the file instead of a string.
Right. So yeah, I was able to do that directly from the command line, but and then it would go and start a goal if I needed to, but then ultimately it would, like, once that was finished, or it had found an answer to it, it would drop me back into the REPL again.
Huh. Yeah, I don't know. It was a strange experience actually being in the. I didn't know what to call it, but I started reading another book about Prolog, and it called it a listener. You've
What book
got
was that?
your prompt. What book was that?
Yeah.
It was Adventure in Prolog by Dennis Merritt, and I may talk about that in a minute. It's a really cool book. But yeah, so your command prompt is a question mark dash, and then I don't know why it does this, but whenever you type a closing parenthesis or a closing bracket, your cursor moves to the opening bracket. But if you keep typing, you'll type it at the end. So I don't know why it does that.
So I mean, in doing it, if I just going and testing it right now, if I write paren hello paren, it goes to the original one, and then it actually goes back afterwards. So it's kind of like if you use Vim on the command line, where it lets you know, like, what was the starting position of that bracket. So if you're nested a few levels deep, you can kind of get an idea.
Oh, I never waited long enough to see it come back. I just started typing, and if I typed, it would come back. So it's like a visual confirmation to know that you're matching your brackets correctly.
Right.
That's very cool.
Yeah. A nice little perk that they have going there. I also noticed if you do things like hitting Control C in it,
mm-hmm.
and you end up getting a help menu. So rather than killing it immediately,
yeah,
it gives you that.
That was really nice. Another thing is Control P works to go to the previous command, as well as up arrow.
Yeah, so they're nice and give some read line support.
So there's not a lot to the syntax, really. You know, there's variables and there's atoms, ATOM, right? So an atom, it looks like a variable, but it starts with a lowercase letter, mm-hmm. and then a variable usually starts with an uppercase letter. So that was something that was kind of weird at first.
You said it usually does? What is the case that it doesn't?
You can. I
guess there's.
You can start a variable, of course, with an underscore, and if it's just an underscore, it means I don't care. I don't like anything will unify to it or something like that, right?
Mm-hmm.
And also variables can include any symbol and space if you put it in quotes.
Interesting. I didn't
realize that, but that can be really useful because I wanted to make a family tree of the British royal family, and I wanted to be able to use their real names instead of coming up with some sort of like variable name that represents their name.
Mm-hmm.
And so being able to do a variable that is inside of strings allows for that.
Right. So a variable inside of strings, or an atom?
Oh, sorry. I got that backwards.
Okay.
A variable does start with an uppercase letter.
Okay.
And an atom usually starts with a lowercase letter. But you can put anything inside of quotes instead.
Okay. That makes sense to me now.
Yeah. Yeah, it's really confusing because I guess one way to explain it is you might write out some facts using atoms, saying like Wallace likes sheep, Gromit likes cheese. And then when you're doing a query, you can use a variable in place of one of those things. You can be like who with an uppercase W, like who likes cheese, and then it would figure out all the things that can match cheese with the fact likes. That may be a weird way of saying it, but it finds all the possibilities for that variable.
Right. Yeah. So, day one definitely, like, it wasn't. I wouldn't say that like it was a real big challenge. I mean, because it was mostly just going and following along with the thing. I did go and find the documentation for GNU Prolog, and it looks really old school. With like it.
Well, any GNU website's going to look really old school.
I guess that's true. And,
it's just HTML, right? There's probably not any CSS.
Right. Yeah. I mean, they have some coloring behind stuff.
Okay.
So
I
yeah,
do appreciate they give you an option if you want all of it on one page, and that can be useful if you want to do a Control F or Command F.
yeah, definitely. And or to like go and save the whole thing. Like if you wanted it for offline purposes, that would actually be pretty convenient. And it's I mean the documentation was nice in terms of like they had a lot of like I mean they seem to cover things there. I think the biggest thing that is missing for me in it is lack of examples.
Yeah, for sure. I found some other tutorials that are nothing but examples, and so those are really cool.
Yeah, I think that I don't know, with that it would make it a little bit nicer of an experience because I spent some time looking at a couple of things and was just like, I don't know, like I can see that what this is and I can see the description. And I do like that they actually call out the errors to say like this is what the error message is, and like this is the kind of code that you'll get, like instantiation error, and the actual like the real message is that socket is a variable, and so I mean it's nice that they go and document it. It would be kind of nice, like even nicer if in the REPL itself it gave like the more human readable message alongside it. But at least they do have that, because it is nice to know why things are going wrong, because even as they explained in the book with the like the dolphin keeper or dolphin researcher, which I thought was kind of a cool usage of a Prolog, was to learn about dolphin patterns.
I wanted to mention this interview. Like instead of talking with the creator of the language, like he did with the first two. Are we in the third one? Yeah. He talks to a dolphin researcher, who is someone that used Prolog for a practical thing for his job. Were you gonna say something about?
Well, yeah, I guess like the one thing that they called out was that sometimes Prolog seemed like an all or nothing approach to problems, where you would try something or it would say no.
Yeah, you have too many constraints.
Right.
And it's like, well, why? What's wrong with it?
Right. Yeah, there's no guidance.
Kind of a black box
beyond that. And I mean, sometimes it felt like even some of the exceptions were kind of like that. I mean, I started getting or improving a little bit at being able to read the errors. And it's like any new language, you have to be able to understand the error and not just throw your hands up anytime it says error, because that happens a lot, especially early on.
Yeah. So I love one thing in this interview with the dolphin researcher. He says when he first started out, he tried writing something like x equals x plus 1, and then Prolog is like, no. And he was like, what? Languages don't just say no. And, they might have an error or not compile or something, but they don't just say no. And he called Prolog support, and they kind of explained it. But I thought that was really interesting. I've never called support for a computer programming language. I didn't even know that it ever existed.
Oh, I didn't. I guess I would think of it with something like a more proprietary version. I mean, because I guess some of it is like it's common to use languages that are open source with pretty lenient licenses that don't come with much in the line of support. I mean, other than like a forum or something.
Right.
But there are things like with I think Microsoft with C# and .NET. You can get a level of that like that, and
yeah.
But like you said, like I've never considered I'm going to call up support on it. So
yeah.
But it also, I mean, is from an era pre-Stack Overflow, right?
Absolutely, yeah.
Where it says I learned it in the 1980s. Like, I mean, you.
Yeah, and this language is from like 1970.
Yeah, I think it said that it's one of the oldest languages in here.
Yep, 1972. Oh, and I don't think it mentions it, but Prolog stands for Programming Logic.
That makes sense to me.
Seems logical.
Yeah, I mean, it does make me think back to even, I mean, I took logic in college, and it was very much like you have these things, like therefore, like P and Q, therefore P and Q kind of thing. Like,
Yeah.
Prolog would be pretty keen to say, yeah, that's cool.
Yeah.
So,
all right. What about from day 2?
Day 2? Day 2 was really enlightening by writing the concatenate function again. I guess less so about the writing it factor. I mean, it was nice to get the exposure to the recursion, but just the fact that you can go and use a rule or goal in multiple ways, like that you can use. I guess append is the built-in one, right? Yes. So append is the built-in one, but given the positioning of your variables, you can say that because append is one that takes three arguments into it, and if you specify the first two of, like, say a list, which is just square bracketed, of 1, 2, and then 3, 4 and as the second one, and then specify a variable for the third, then Prolog will be able to tell you that it's 1, 2, 3, 4 if all of those are appended. And then also you can go and specify that you have 1, 2, then a variable, and then 1, 2, 3, 4 is your final one. And then Prolog will tell you, well, here's the difference, or here's the part that you didn't specify. So like it will give you the later two of the array, or list, I should say. And they pointed out 4 different ways to use that same one, and like use that same one in multiple ways. Whereas generally when you're writing a function in most other languages, like you have to write a function for each purpose. You have to say like includes or concat, but in Prolog, append can work for all of those cases.
So you're saying the one rule, append is a rule, right?
Mm-hmm.
Can do multiple things depending on how you write your query?
Yeah, so depending on where you put the variables in it.
Okay, yeah, so when you're doing a query, you put some atoms in there, you put some variables in there into like the different parameters, and then Prolog will try to resolve the variables into what values it could have.
Yeah, it will unify them. That's kind of their term. Like it will try and make them equivalent on both sides of the goal.
Yeah. In this step-by-step about how concatenate works, with an example of passing in 1, 2 for the first list, the second list is just 3, and the third one is the variable what. Just walking through that, it's such a mind bender. And also, I think you have to think about it differently. You can go into Prolog thinking how it's going to work imperatively step by step, and it kind of walks through those steps. But there's another sense in which you can think about it, and you're not necessarily thinking about what steps it's going to go through. You're just thinking, well, here's the rule. If it meets the rule, then that's the answer. And it's so weird. And in this other book, Adventure in Prolog, it talks about for every kind of Prolog terminology, there's also an imperative terminology to go along with it. So in Prolog, your program is called the database. And well, maybe I should look at some other examples. Let's see. Yeah. So, and then in Prolog you have predicates. Well, never mind. I won't go down that rabbit hole.
Okay.
I will say another thing to mention is that each predicate you write, or each rule you write, is defined by the name of it / its arity. So how many arguments it takes, and that's kind of important. And one thing I stumbled over is when you're writing your clauses, you have to have all of the same type together. So, for example, I was writing the British royal family, and I was saying, okay, this person's a male, this person's a female, this person's a male, this person's a female, and it said you can't do that. It's after you do male and then female, it's going to ignore all all the rest of the males that aren't like right next to that one.
Interesting. I
Yeah.
didn't run into that, but
Didn't run into that because all the examples in the book, you just write them together. It just makes sense. But in my mind, you're writing male, female, female, kind of made sense because I was trying to go in chronological order and just specify which one they were. But the name of the fact was male or female rather than like I could have had the fact called gender and then given it the atom male and their name, and that would have been fine.
And you said that it just ignores it?
It throws a warning and it tells you it's going to ignore it.
Okay. Yeah. It did give me a couple of useful warnings. Like if I used a variable just once, then it gives like a single variable warning or something. So if you created a rule and
I've seen that.
And you didn't use the variable multiple times in it, then you probably were doing something wrong. Like you probably intended on using it, but you didn't. So
right. If you have a variable in a rule and you don't use it, yep.
Yeah.
Yeah. So in each statement, I don't even know what to call them. Statements, queries, rules. They all end with a period, and then within a rule, you can have different goals separated by commas, and the rule has to satisfy all of the goals that are separated by commas. So it's the comma's kind of like an and.
Yep.
But you can have another rule if it takes in the same number of parameters, then it has like the same name because it's the same name and / Arity. So that's kind of like an or. It can satisfy either rule. And that's used a lot of times for what's kind of like your base case for recursion. You might say an empty list and empty list. Does that make sense?
Yeah. Yeah, to me it kind of read like pattern matching in a sort.
Or maybe I should say like empty list, comma, 0. If those are the two parameters for count. That's your base case. An empty list has a count of 0.
Yeah. Have you worked in any languages with pattern matching?
Oh, I've seen some pattern matching in, what's it called? Crystal? Is that one?
Crystal, the Ruby that is...
Okay. Yeah. I think that one.
Yeah. Well, we'll likely get into it next time as well with Scala because they definitely have it. But it is very much like that where you say, like, if I get this as my argument, like if I get an empty list, then always do this thing. So that's what it, like you can go and define a function multiple times, and at least it kind of looks like it's defined multiple times, and you say like, given that the arguments match this, take this approach. So it cuts out
and
a
it's
bunch
weird
of
too because
kind of conditional.
It's not saying given an empty list return 0. It's not returning anything. It's just saying empty list count empty list 0. And then depending on how you query it, you can say, well, what's the count of an empty list, or what kind of list has 0 as the count? Yeah.
But there is like no return,
it's just unifying variables to value.
Right. Which in one sense is kind of powerful as well because you can not only have, because you can kind of use one as a return value, but it doesn't even have to just be one. Like you could kind of have...
It's like multiple return values, right?
Yeah. Like if you wanted that, like I mean, it's not too often that I had to have a need for that, but it's also, I don't typically work in an environment where that's a common thing to use. And so I'm sure there are really good justifications at some times.
Well, I mean, in day 3, the Sudoku example, you only pass in a few atoms, and those are the numbers that you know at the beginning of the puzzle.
True.
All the rest of the values are returned to you, essentially. I shouldn't use the word returned. All the rest of them are unified.
Yeah. I guess getting on with that. I mean, do you want to hop into day 3, or was there anything particular in day 2 that you found interesting?
The self-study was extremely hard, and I couldn't finish it.
Yeah, I did.
But
I did not,
it was fun and mind-bending. What'd you say?
Yeah, I did not get terribly far in day two's self-study. I did run into the not expression issue where did you see that one where there's what are some of the problems of dealing with not expressions?
Yeah.
And I actually ran into that. I think it was considering the state problem where the states had to be different colors, and you had to explicitly say like these are different
No, I don't
as
think
part
that's
of your
it.
facts. Well, I mean, well that was it was the case that I was thinking through of like you explicitly stated that, and so I actually tried to go and write code that would unify just by saying this is not this.
Okay.
Like um the color of Alabama is not the color of Mississippi, like that, and writing it that way.
Okay.
Maybe that was it, or maybe it was even simpler with just like the friend one, because I think even there like the rule is written um Wallace likes cheese, Gromit likes cheese, and Wendelin likes sheep, and that one actually uses a not. And so you can ask Prolog if these people are friends, but you can't actually ask like you can't pass a variable in for that.
Oh, right. So
For like you can't ask who is like you can't say who is a friend of Gromit, because not cannot unify, because not means anything in one sense. Like as long as it's not that atom, it could be any atom, and so it won't unify to a variable. So you can pass it an absolute and you can get a yes or a no, but if you go to a variable, like it won't give you a list.
yeah, I looked up the errata, the errors for this book
Mm-hmm.
online because I found a couple, and when I was looking that up, someone mentioned this example, and they mentioned that you couldn't query it that way.
Mm-hmm.
And they actually said if you write the rule differently and you put the not as the last goal, then it works.
Interesting.
Yeah. But let me explain an example that I think will make really a lot of sense with not.
Okay.
So let's say you have a rule that explains who is married. So you say married who, and then it'll give you a list of all the married people, right? If you wrap that in a not, you might expect it to give you the list of all the people who are not married, but it actually just returns no, because married who gives you a result. Not of a result is no. Does that make sense?
So say that one more time.
So when you say married who, it gives you a list of all the people who are married.
Yes.
And so that query succeeds.
Mm-hmm.
But if you wrap married in not, so you say not married who, it just says no. Because married succeeds, the negative of that just fails.
Interesting. Yeah. I
So
can see that.
it can't like it's not like it can take a subset. Like negating a subset does not give you the opposite subset.
Yeah. Well, I mean, it almost seems like it would be in when like of the subset of everything, like is that not like an unbound set? Like if you have a subset of everything, so these are the people that are married. Anything else is fair game.
Yeah, you would think so.
But yeah, I did bump into that though, and
Yeah.
and there were discussions on that, as well as using equals versus is, and I'm still not totally clear on that, where like which one is appropriate for a given case. And there was also something like an equals with a colon, like equals colon equals, I think.
Oh, okay. I never saw that.
Yep. So that was another one too that that I had run into, because I was doing FizzBuzz and I wanted to say that something is, and maybe I changed it up so I don't have the exact example. But either way, ran into a case where those were different, and that's a case where you have to understand like how Prolog is actually going and evaluating your query, and sometimes like if a variable is not unified, like you can't use it on that side of, like on the left side of an is or something.
Huh.
So
Yeah.
Um,
So many weird things.
yes.
But one thing I thought was really interesting at the end of day 3, it's kind of talking about imperative versus declarative languages. And a really good example of a declarative language is SQL, where you don't tell SQL exactly step by step how to look things up in the database and join them. So it says, we would never think of doing a SQL 9-table join imperatively. Yet, we don't even blink at solving logical problems in this way. And so it kind of just challenges your assumptions. Why do we write out logical problems imperatively? Do we have to do it that way? Maybe we don't.
Obviously, we don't, given Prolog exists, and there still is a community of people who do it. In fact, I think it was today on Hacker News, there was a top thing called SWISH, which is a notebook similar to like Jupyter for SWI Prolog.
Oh, very cool.
And yeah, I didn't go and spend much time with it because I had already invested the small bit of time into GNU. And after having done this, I feel like I would like to go through, or like if I were to go and do this again, I would set myself up against SWI instead, because I feel like when I was searching for Prolog related things, that it seemed to be the more common one to pop up in places.
Yeah, I saw that too.
So if I were to pursue it, that'd be where I'd go. Because I mean, on the Prolog Reddit, they talked about web programming in SWI Prolog. So
and SWI's website looks more modern for sure.
Yeah, but I mean, like you said, it's kind of GNU fashion to be old-fashioned looking.
Do you have anything else in day 3? And then I can talk a little bit about this other book.
So I guess 2 things on day 3. First, I had never written a Sudoku solver, and doing it in Prolog kind of felt like it was on cheat mode. Like,
yeah,
because you just go and specify like
you just describe the rules of the game.
Right. Yeah, it is a perfect place for using a logic language like Prolog for. And so expanding it from being a 4x4 to a 9x9 was just writing more rules.
It was just a tedious task of writing more rules. Yeah.
Right. Yeah. Making sure that I replaced my lines correctly.
Yeah.
And I mean, Vim helped out with that.
Same. Yeah.
And I think it was one of the exercises in day 3 where they asked about Prolog has input-output features as well.
Right, yeah.
So I did actually do some input-output in Prolog. And I went and I wrote I talked to you the other day, and I had written an Echo server, and I extended it to actually be a Gopher server. So are you familiar with the Gopher protocol?
No, I'm not.
Okay. Well, there was a time where HTTP was not the only cool kid in town when it came to Yeah, like if you wanted to have documents on the web, Gopher was also a thing where it in one sense it looked similar to how HTTP is, where you would give like / separated paths. And it was super simple though, so like no headers or anything, but instead you would like the client would go and send a path, nothing else, no headers, just here's the path that I want, no get, post, or version, and in response the server would give back just a new line separated list of like menu items that would say like if the line started with 0, then it would be a text file that it was linking to, or if it started with 1, then it was like another menu. And so like there are these defined types that could get returned, but it's all like a very text-based web the experience.
Okay.
And in short, like I went and kind of using some guidance from a person who went and wrote an HTTP server in Prolog, I was able to use Prolog's wrapping over the BSD sockets, which are they're a pretty standard socket interface, but they've made them into more of a Prolog API, where instead of returning, you just have to pass in a variable, and you say, give me a socket that is a internet socket, and then you have a socket. And I guess I guess you have a file descriptor that is the socket, so you actually get like a number back out of it. But then you bind the socket, so you say, I need to go and attach this to a specific port, and you start listening on it, and also you say that you want to accept incoming connections on the socket. And then after you do that, Prolog will sit there and block until something comes in, and then you get a stream in and a stream out from it, and you can work with those things. And what I thought was kind of cool on the stream in is that for reading from it in a series of like 3 rules and using concat, atom concat, which is similar to append, but it's for concatenating atoms rather than a list. You're able to use that as a rule to define when you're done reading a line. So with atom concat, you say, all right, here is, so I have a variable that is my line, and then second argument passed to it is a new line character, and then the third thing that I pass in is the content that I've received so far. And so that doesn't wind up being true or yes until there is a new line that it ends with. And so just with that and a couple other rules, it was able to go and read a line. And then I parse it, and then I have a bunch of facts about that map between a atom and an output that should be there. So they're like routes that exist. So I will shoot you a link over to that, because I upgraded my Echo server to that today, and it feels pretty cool to have a Gopher browsable thing, because I went and fired up a Gopher client called Lynx. I guess that's an old web browser as well.
Wow. Yeah.
Text-based.
Is Gopher still in use?
Yes, it is still in use. There are various things that use it. The biggest community for Gopher is, I think it's sdf.org.
Huh.
And they host a whole bunch of Gopher holes, because that's what they call those things. And
I'm kind of glad HTTP, if it was a competition between HTTP as a name and Gopher, I'm glad it's HTTP.
I mean, we could be in a totally different realm now, but
yeah, alternate universes.
Yeah. All right. I want to hear about this book.
That is, I have to say, I didn't understand a lot of that, but that's cool, really cool and fascinating, and one of the nerdiest things I've heard in a while.
Well, I just know that Gopher is super simple compared to HTTP.
Oh, okay. Well, then that makes sense.
It's just new lines, and so you can write it in very little amount of output. Like, you don't have to structure much. So that's why it was enticing. And I've never written a Gopher server before, and now I have. So
yeah,
I'll check that box.
Yes, add that to check that off your bucket list.
All right.
Yeah, this book, Adventure in Prolog, it's all about creating a text-based adventure game using Prolog. And it says Prolog is particularly well suited to this task, given how it works, and given the way you describe rules. So right off the bat, you can create a map by saying items are in this location. Those are facts. These things are rooms, and there are doors between these rooms. Things like that. And so it's about 150 pages. It looks like it's self-published. It's very simple. I love it. And you just go through, and you don't necessarily write the program in the order you might expect. He kind of presents it in the order that's easiest to learn, and you can do it in that way in Prolog. You can write your program in any order, different parts, and then the most complicated part you do at the end, which is the natural language part. And there's also a few other exercises. One involves a customer order entry application, a genealogical database, and a system that identifies birds. But yeah, it just really opens my eyes to some of the fun things I could do with Prolog. If I just kind of want to play around with something where I'm like, I have all these facts, I would like a system to be able to ask questions of it in a way that you couldn't do with a SQL database. But also creating a text adventure game, that's just kind of fun.
That sounds fun, and it sounds like quite a unique challenge. Like that's a cool book. Like, it sounds cool. Like, when was it written?
That's a little hard to tell, because it's self-published. It just has copyright 2017, Dennis Merritt. So I would think 2017, but the preface is dated 1996. So maybe 1996, and then he just updated the copyright.
Okay, well, I guess given that's the earliest date, you can say sometime in that range.
Yeah.
And I mean, given those are the facts, I believe Prolog could probably tell us what the range would be, right?
Yeah. So, do you have any takeaways or things that you want to do after reading this chapter?
I would say maybe going and tinkering with SWI just a little bit. I feel like it seemed to have some things that GNU didn't. Like, I had mentioned about the not situation where it wasn't totally clear. I believe SWI has diff in it, and that is supposed to say like that's supposed to be different semantically than not, and so maybe a little bit. I mean, I think just having the mind bending that came away with it, and writing a little bit of Prolog, like, helped me understand even like what it is in general, because it is something that I had heard about numerous times in the past, but had never actually sat down to do. And that has been a great part of this, is just now I may reflect on my daily stuff a little bit different because of it. So like, thinking, why am I doing so much work writing this algorithm when in fact all I know, or all I want to do, is take some facts and assert some things about it.
It might be interesting to say, if you were trying to solve a problem imperatively, to say, well, is this even solvable? And then go write a little Prolog program to prove if it's solvable or not. I don't know.
Mm-hmm.
I guess what I really want to ask is, could you ever see yourself using this in your job?
I would say probably not, at least.
Probably not, yeah.
Mostly because, I mean, it's something that's it's not totally straightforward to hop over to it. Like, there are many languages out there that hopping from one to the other, like just in an imperative language, like it's not a huge mental leap. Like, right. I made the jump from C# to Ruby long ago, and then Ruby to JavaScript, and like hopping between those things, while yes, they are different languages and have some like major features that apply to them, like mentally, like it's the same approach. Whereas Prolog flips a lot of it on its head to say, like, no, you're not returning things, but instead you are unifying. And so like, if I were to do that, I almost feel like I would be selfish in the approach to be like, yeah, this is what we're gonna do, unless it
you
was...
mean like, so it wouldn't be a good fit at work because of forcing other coworkers to learn it.
Right. Yeah, that would be my biggest hold up with it. Okay. Also,
mine would be like, what is the performance and how do you run it, and how does it interface with other languages and programs?
Mm-hmm. it's true. There's still
Because
so many unknowns with it.
I think it was the Sudoku example where before there was a slight optimization, which is a non-obvious optimization, it was just sitting there spinning.
Yeah, it was the
and you
8
don't know
queens.
why. Oh, the 8 queens. Okay.
But yeah, it is true. Like you have to understand it at that level. I mean, any programming language, like you run into bounds like that. So you're right. Like understanding what those limitations are, and either knowing how to work through them, and like it's not something you would just jump on and be like, oh yeah, this is the choice, because there's so many unknowns still.
But I feel like it's a really great choice for non-programmers who have a particular kind of problem that would be easily solved by this language. And the dolphin researcher was a great example. He had a certain number of dolphins, researchers, people with particular skill sets and certain schedules, and he needed to figure out when people would be in the room using which dolphins, running which experiments.
Yeah.
So it could be really cool for non-programmers. It could also be cool for like certain niche problems at work. Like, how do you schedule interviews based on people's schedules and conference room availability?
That is true. And I mean, that it does make me think on or make me wonder how it handles things like dates. Because I know one of the things that we do at work is we have reports that need to get sent out on like even like sending stuff out like on a certain schedule, and like me accommodating that, which is slightly different, but managing that front, if it would be something useful there. And I guess in today's day and age where we all cheer for microservices, I mean, being able to have a Prolog microservice that is like totally a black box from everything else, if it's just an engine that you ask questions to, I guess, I mean, maybe it's okay to have some usage in it.
But it'd be really funny if your microservice just says no.
Yeah.
It's like a grumpy cat microservice.
That'd be a great name for it.
Yeah.
Yes.
All right. Well, we better start talking about it. It was super fun, though.
Yeah, I agreed. Definitely mind-bending. It like learning to think in it. Something like you can also look at is a takeaway. Somebody described switching from imperative language over to Prolog is kind of like changing the direction that you see of the spinning dancer. And the spinning dancer is a picture of a dancer that looks like they're spinning either clockwise or counterclockwise to you, but you have a tendency to see one at first, but with some effort you can actually go and change the way that you see it.
Yes. Yeah, it's a very cool analogy.
Yeah.
All right, so next week we'll talk about Scala.
That's right. Looking forward to that.
All right, you can follow both of us on Twitter. I'm at Agarhar. Jason is at Staten Jason. The show is at BookBites FM. We'd love to hear from you. If you haven't left a review, please do that on iTunes, and we'll see you next time.
See ya.